Okay, so now we're actually shifting from traditional cipher to like more modern ciphers. So far, that cipher, most of the cipher that you have seen, even in traditional cipher, most of them are based on stream ciphers. I mean, which means that one bit at a time, bit is being encrypted one bit at a time, or one character at a time, one symbol at a time. Uh, and then of course then I think we looked at AES, which was actually block cipher, and then we're going to look at DES, which is actually another type of a symmetric key cryptography algorithm, uh, which is also block cipher in nature. So modern ciphers are block based, but most of the traditional cipher were stream based ciphers. One of the most powerful cipher, literally, when I say the most powerful cipher, is actually one time pad, and this cipher is still the most robust. A cipher still exists in the universe, but there are certain problems. There are some problem associated with this cipher, so we're going to look at those problems, and we're going to actually look at how simple that cipher is. So here's the equation for it. It's going to be your ciphertext is, let's call it CI, is going to be PI plaintext plus XOR with KI. That's it. And your decryption, your plaintext, is going to be CI XOR with KI. That's it. That's how simple it is, and is like still it's hard to crack. And if you still want to use it, you can still use it. Okay, so for that, just to use an XOR operator, what we're gonna do, we're gonna look things in terms of bits now. All right, so we're gonna look at the things in terms of bits. So let's just say I have a key. In order for this, why we are calling it one time pad is that's why we're calling it. If my message is 10-bit long, then my key, example, also 10-bit long. All right, so if I have a 10-bit a message, then my key has to be 10-bit. If my message is 1 gigabit, then my key has to be 1 gigabit. All right, if my message is 10-bit, so for the sake of example, if my message is 10-bit, then my key has to be 10-bit as well. So for every individual character or every single bit, I will have an individual key for it, which makes it impossible to break. So if my data is 1 gigabyte, if I'm sending a 1 gigabyte file, then I gotta have a 1 gigabyte of key as well. Now, if I were to use this cipher in modern nowadays, how am I going to do that? So for example, if I have 1 gigabyte, I need to send 1 gigabyte file, encrypted file, then I have to also send the key, which actually will choke my network, isn't it? Because in order to just send 1 gigabyte of file, I gotta have 1 gigabyte of key as well. And just to send the file and just to encrypt that file, I gotta have a same size of key, which makes it impossible for you to use nowadays in current electronics or in current information age. So I think in previously what used to be done, that if someone wants to send a message, he might encrypt using one time pad, and he will send that encrypted key with someone else, and then encrypted text with someone else, and might send a key later with someone else, so people will look at the key and try to decipher what's going on. Also, you need to remember, here we're using modular 2 arithmetic. Modular 2 arithmetic means addition and subtraction is same. Addition and subtraction is exactly the same. XOR is the operator that is widely used in cryptography because the output of XOR is random. Why? Okay, let's look at an XOR table. Let's look at 2-bit table, 0 0 0 1 1 0 1 1. What is the output, guys? So if both bits are different, which means it's modular 2 arithmetic, 0 plus 0 is 0, 0 mod 2 is 0, 1 plus 0 is 1, 1 mod 2 is 1, 1 plus 0 is 1, 1 mod 2 is 1, 1 plus 1 is 2, 2 mod 2 is actually 0. So within four with using 2 bits and developing a true table of it, I can already see the output of zeros and one are 50%, which means the output is random. That's why we love XOR operator in cryptography, because the output of this operator is quite random, because 50% of the time zero will occur, 50% of the time one will occur. The reason, one of the reason, so I hope you understood the reason why we don't use it, because in order for me to send a 1 GB file, I need to send a 1 GB of key on the network, which actually chokes my network. So if it's a file is a 10 GB file, I have to have a 10 GB of key, because for every single alphabet or every single character or for every single bit, I need to have an individual key. That's the problem with this cipher. Second, it's actually one-time pad. One-time pad means once you use that key, you cannot use that key again. You have to destroy that key. You cannot just continuously use that, because that happens. There was a project called, I think, Project Venona, during the time of Cold War. If I'm not mistaken, you can Google it, Project Venona, in which I think the Russians, so the allies were using, they were capturing their messages, which are being encrypted using one-time pad. And one day they decided, okay, we're going to use the same key, and that became the fall of this. So one-time pad means for individual, if I have a message, once I use that key, I need to destroy that key. For next message, I gotta have a different key. All right, so how simple it is. So let's say I have a plain text. So let's do an example. Let's cut this chit chat and let's say I have a plain text, which is in terms of 00110011, and let's generate the key. I can use any pseudo random algorithm to generate this, or I can take a coin and I can flip a coin. For head, I can call it 1. For tail, I can call it 0, just to get a randomization output. So let's say, okay, the key that I've selected is 100110001. All right, so this is my key. So I'm using, what I'm gonna do, I'm gonna just simply XOR it. All right, so let's encrypt. The way I'm gonna encrypt it is I'm going to take my plain text and I'm going to take my key and I'm going to XOR it. Okay, so 1 plus 1 is 2, 2 mod 2 is 0, 1 plus 0 is 1, mod 2 is 1, 0 plus 0 is 0, 0 mod 2 is 0, 1 plus 0 is 1, mod 2 is 1, this is 0, this is 1, this is 0, this is 1. So this is my encrypted data. All right. So once I get my encrypted data, so let's decrypt this data. So I have my encrypted data. The key is being shared, since it's still a symmetric algorithm, which means key is being shared between my sender and a receiver. So I'll take my decrypted data. So I'll take my ciphertext, which is 10101010, and I'm going to encrypt that. I'm going to decrypt that with using my same key, which is being shared. So I'm going to write my key as 10011001. So I'm going to do the same thing. I'm going to XOR it. So 01 is 1, 1, 0, 0, 1, 1, 0, 0. This is exactly the same as my plain text. So I got my plain text. Why? Because in modular 2 arithmetic, addition and subtraction is same in modular 2 arithmetic, which means I mean to say XOR operation. So I'll get the same thing back. The operation is exactly the same. So these were some of the problems with one-time pad, but if you still want to use it to encrypt the smaller files, this is like one of the most robust cipher that provides confidentiality. Yes, there are some issues which are associated with the integrity of a system, because anyone who can capture this and XOR another type of data with it, and it will, the message integrity will be lost. But in order to achieve confidentiality, this is still one of the best cipher that exists, and you can use it. Anything else I want to say about this? I hope you like this small tutorial on one-time pad, the usability of this pad, this cipher, and if you have any questions, do leave it in a comment section, and don't forget to subscribe to my channel.